In this video, we're going to explore covalent bonding and how we can represent that through dot and cross diagrams. Covalent bonding is the bonding between non-metals through the sharing of electrons. The covalent bonds themselves are very strong, but the intermolecular forces are weak, resulting in simple covalent structures having low melting and boiling points. In the diagram, you can see ammonia. The solid line represents the strong bonds between the nitrogen atom and the three attached hydrogens. The lighter dashed lines are representing the weaker intermolecular forces. Here we can see a hydrogen atom and a chlorine atom, and they each need one more electron to complete their outer shells. The sharing of one electron from each atom creates hydrogen chloride and fills each atom's outermost shell. This makes the atoms more stable and they will not want to react further. These bonds are so strong as the positively charged nuclei of each atom are attracted to the shared pair of electrons, meaning the bond will require lots of energy to break. In the previous example, both elements only made one bond. However, some elements will need to make more bonds to complete their outer shells. You can calculate the number of bonds needed for nonmetals by taking their group number and subtracting it from 8. For example, nitrogen can be found in group 5 and can make 3 bonds. In this bond diagram of ammonia, you can see a lone pair. This is a pair of electrons that isn't being shared with another atom. The nitrogen added 3 more electrons and each hydrogen atom has provided one. The remaining 2 electrons from the nitrogen can be paired together without a bond. This diagram of carbon dioxide shows double bonds between the central carbon atom and each of the outer oxygen atoms. This is because there aren't enough atoms and electrons available for more bonding to take place. You'll notice that each of the atoms is still making the correct number of bonds, as double bonds count as 2. The key thing to remember is that you're trying to fill the outermost shell of an atom. With the exception of hydrogen and helium, this means having 8 electrons in 4 pairs.